Okay, so here class 10 chapter 2 acids, bases and salts. Okay, this will be your video 3 and this portion will include the portion. Okay, test 2b. Okay, this will include question number 17 to 30 of your tuition note. So you please write that down as I'm writing. Follow me. Okay, now here question number 17. Question number 17. Let's just do this first. Now we know from the last class that when carbon dioxide is passed through lime water. Okay, so write down the equation on the left hand corner. Carbon dioxide, write the formula above it. You know the formula, right? CO2 is passed into lime water. A little bit below the plus sign, right? This is the common name, lime water. The real name of chemical name of lime water will need to write the formula. So the real name is calcium hydroxide. So you write that down, and using that you make the formula up here. Okay, remember your starters. Calcium ion is Ca2 plus and hydroxide ion OH1 minus. So here 2 valency and here 1. This 1 need not be shifted, but the 2 here, when you're going to shift, we need to put a bracket and bring down the 2 behind the OH, lower backside of OH, because OH is a compound ion containing more than one atom, right? So when these two react, last class we saw that, just below the arrow, we saw that a milky white precipitate was formed. The word precipitate means solid, so not soluble in water. Okay, and the name of that white substance is, we learned in the last class, calcium carbonate. Okay, calcium carbonate, write it down. And now you make the formula above this one here, Ca 2 plus and carbonate is CO3 2 minus. So 2 and 2 cancels, so you get that. So this is a solid. You can write there as small if you want, and if you don't write that, it's fine. And the other product we learned is always your water. So you write the formula there, water. Okay. Now this water here, the milky white substance is not soluble, so obviously it is by appearing as white solid. No? Now that what happens when we pass carbon dioxide through the lime water. But today's question is, they're asking this one, when we pass, instead of normal amount of carbon dioxide, excess carbon dioxide, this is what they're asking, what will happen? So when we pass excess, this reaction will proceed to the second step. So do you write this one down? Right side the product CaCO3 plus H2O. So this one that we got when we pass normal amount of carbon dioxide will proceed on and add to more carbon dioxide. So you write the CO2 excess. This is the excess that you're passing. Suppose we pass excess. And finally, the milky white will disappear and you will see a colorless solution on the right side or in your test tube. Why? Because so you write here solution turns colorless. So we want to know why the milky white has disappeared and the solution turns colorless. This is because a substance called calcium bicarbonate, you can write it down, calcium bicarbonate, just below the arrow you write. So make the formula now above the name. Starter, calcium Ca2 plus bicarbonate ion HCO3 3 1 minus, so this 1 and 2 can cancel, 1 cannot be shifted, so when shifting this 2 to the lower backside of HCO3 we need to put a bracket, because bicarbonate ion is a compound ion containing more than one type of atom. So that's it, that's the product. Now we forgot to do this, we have the balance now, 1C, here also 1C, this is not C, this is calcium Ca, okay. O2 plus 2 1s are 2, 2 plus 2 4 O on the left side. On the right side 3 plus 1 O 4, so balance so far. Now Ca1, here also 1. O just now we did, no? So go to H, bracket means inside this 2 belongs to H also, so 2 1s are 2H. Right side H2, so this question is automatically balanced. Let's balance the next one. Here Ca at the back 1, so here also 1, Ca1, the balance so far. C is not the Ca, this is carbon, this is calcium carbon, Ca calcium, C carbon, you speak like that to differentiate, okay. C plus 1 plus 1 is 2, right, and here also there is a bracket, so 2, no number here means 1, so 2 1s are 2C, this is also 1 plus 1 2C, left side 2 carbon, right side also 2 carbon, so balanced so far. 3 O, how much, 3 at the back here 1, so 4 at the back here 2 5 6, 2 3s are 6, so this equation is automatically balanced. So because the calcium carbonate is formed, the solution turns colorless. Why? Because this substance, calcium carbonate, sorry, bicarbonate, is soluble in water, okay. Here it's the milky white is appearing because calcium carbonate is insoluble in water, but here the milky white color disappears because excess carbon dioxide allows it to form calcium bicarbonate, which is soluble in water and colorless, okay. So that's the thing. So you go and read question and answer of 17 yourself. What happens when excess carbon dioxide is passed through the lime water? Write the reactions, you will understand yourself, okay. So we've done the reactions here, the two-step reaction for that. So you can pause the video and read through it and then replay the video for question 18, okay. Now here question 18 is just a GK kind of question, so we'll just go through it. Limestone, chalk, marble are all different forms of calcium carbonate, meaning all these common substances are calcium carbonate itself. The answer is here, so there is nothing to explain, just memorize it, GK kind, general knowledge kind of question, so yes. Now next question, important. How do acids and bases react with each other? So let us read that. 19 and 20 will combine, okay. So here question number 19, question number 19 and 20 you also write likewise, and then we will combine these two. So here you take two test tubes, okay, one of them containing base and the other one containing acid. So let us say we take 2 ml of dilute NaOH. So this is sodium hydroxide, which is the base, the solution, okay, 2 ml around you take. Then in the test tube and add 2 drops of phenolphthalein. So here you add 2 drops of phenolphthalein, okay, phenolphthalein. So as soon as you do this solution will turn pink, because you know phenolphthalein is pink color in bases. We learned that in the beginning of the chapter, no? That bases turn phenol. In bases, phenolphthalein is always pink, and in acids it is always colorless. So here what do? You now take some dilute HCl, okay, dilute in the other test tube. So this is the acid, so you write down acid. Then you add this one here dropwise. Dropwise means don't pour it suddenly, but with a dropper, tuk tuk like that, drop by drop you add the acid. So as you add this dropwise the acid, you will see a change. Interesting. Number one, pink color begins to fade. I hope you're writing the same thing. The best way, easiest way to learn is learn by doing yourself. So you better write, okay? Pink color begins to fade. Fade means the color begins to decrease, okay? Then finally it turns colorless. So continue to add drop by drop. Then you will reach a point where the color has become so thin in pink, thin, very thin pink. After that also, if you add 4 or 5 drops, turn colorless. You want to know why it is turning colorless? Because you have added 2-3 drops. After the color become thin, 4 or 5 drops, the amount of HCl has overtaken the amount of base, and you know that phenolphthalein is colorless in acid. So because the strength of acid is higher than the base, after some point of time it has turned colorless. So this reaction where the acid is poured slowly to cut the action of base is called neutralization. Okay, so neutralization. So let us now write the equation that we have done the experiment on just now. So here we took here sodium, just keep a gap here, okay? Sodium hydroxide, right? So you take that, write the formula above it, Na1 plus OH1 minus plus plus. Remember your starter, okay? Then we don't need to memorize formula. Then this is the base. Then you added the acid, so you write here hydrochloric acid, which is primarily hydrogen chloride chemically. If you want, you can put AQ, meaning dissolve in water. But if you forgot to put, that's not so strict, okay? So you are adding a base to an acid. And this right hand side product you don't have to memorize, okay? Follow this trick. On your practice copy you make this box, Na is plus, no, Na plus. So plus always combine with minus, negative radical. So H is plus, so we cannot combine with H. Make this box and combine, join those two boxes, you'll get NaCl, right? So make a box. Previously you were writing the formula from the name. Now this time we are going to write the name from the formula, which is equally important. So let us write this down. Yeah, yes, this is sodium, Na is sodium, and Cl, the chloride. Okay, so now plus, outside the box you see what are they, OH plus H. What is the only correct compound you'll get from there? Yes, that's right, HH plus is H2. Water you'll get, this is correct. No box, outside the box got this one. We don't need to balance this equation because you took the boxes and got exactly this. Outside the boxes you got exactly this, means it would be already balanced, right? So this type of reaction where this base is combining with an acid or reacting with acid to give you, this is called sodium chloride, is called salt, okay? Salt. And usually we also get water as the byproduct. In some reaction you won't get salt, okay? Or you don't get water, but salt is always there, okay, in acid and base reaction. This reaction in which an acid react with base or base react with acid, up to you. Acid plus base or base plus acid is same to give salt, and water is called neutralization reaction. So today we have learned what is neutralization reaction. So go and read question number 19 and 20 yourself by pausing the video, means stopping the video, and then after you're clear about it, replay the video and go to question 21. Okay, we'll combine 21 and 22 next. So here, write down question 21 and 22. Okay, so let me read the question for us. How do metallic oxides react with acids? Explain with example. So that's enough. How will metallic oxides react with acids? So just take a real example. Okay, keep some space here and write here copper oxide. Just write it, make the formula above it. Yes, copper is Cu2 plus and oxide is O2 minus, so 2 to cancel. So this is a solid if you want to write. Okay. So here copper oxide, the textbook in this question has not mentioned the color, but I want to mention the color because it helps us to understand. Copper oxide is blackish in color, okay? Then you add to this hydrochloric acid, okay? Hydrochloric acid, drop by drop, slowly. So HClAq. Then what will happen? As you add this one drop by drop, they will react and you will get a new substance, okay? And the new substance, before I tell that, now the black color disappears and turns blue, okay, blue green color, blue green color appears, okay, blue green. So definitely there is a reaction taking place because the black color is disappearing, means copper oxide is disappearing. Blue green appearing means a new substance is, new color means new substance is formed. Why it is turning blue green is, you want to know why. The reason is just below the row you write copper chloride is formed as this reaction happens. Copper chloride is formed, okay? So write the formula Cu2 plus Cl1 minus 1 and 2, so 2 will go to the back of Cl, no bracket because Cl is only a single ion, simple ion, single, not two types of atom but one type only there. So this is turning blue green. Now the explanation is coming because copper chloride we know is always blue green in color. Okay, that's excellent. Then the byproduct you're going to get is, just remember it, water, a little bit below the plus. All right, the formula of water. So the next important thing for us to do is balance them. So here Cu1, O1, here also 1 on the right side, H is 1, here H2 at the back. So we cannot balance from the back or between our back, so we have to put the 2 to make it equal to H, slightly bigger it is 2 back. Okay, so 2H and H2 balance. Now 2Cl and Cl2 balance, so let's check one. So C1, O1, 2H, H2, 2Cl, Cl2. So this is now balanced. So here we see that the copper oxide, just now we learned in neutralization that only this is acid, right? So only a base can react with an acid to form what? Salt. Just now we learned, and water. We learned that only a base can react with an acid to give salt and water. Now copper chloride is nothing but salt. So since copper oxide is reacting with acid to give salt and water, surely copper oxide is a base. This proves that metal oxides are basic because copper is metal now, so copper oxide is metal oxide. So this is your explains how metal oxide reacts with acid to give salt and water. So metal oxides themselves will be basic in nature. Okay, so go and read question 21 and 22, pause the video and read it, and then start replaying the video to go to question number 23 and 24. Let us combine again. Okay, so here question number 23 says, how do non-metallic oxides react with bases? So this is the opposite of question number 21, 23. So take an example again. I'll take here carbon dioxide. Okay, write the formula yourself. Yes, that's right, carbon dioxide. So this here copper is metal, so this is metal oxide, copper oxide is metal, but carbon is non-metal, so carbon dioxide will be non-metallic oxide. So how do non-metallic oxide react with copper? That's why with bases. That's what they're saying. How do metallic oxides react with acids? How do non-metallic oxide react with bases? Opposite. Okay. So take a base, very common, let us take this base rather, calcium, a little bit below the plus sign, okay, calcium. Hydroxide is a basic substance, it's a base. So write the base. And above the calcium hydroxide, you write the formula. Yes, Ca2 plus OH1 minus, so here at the back, 2. What would you get? Remember this, okay? This one, the name you remember because you need to write right side. Calcium carbonate you will get. So write the formula. At the arrow point, Ca2 plus, CO3 2 minus, so 2 cancelled. And definitely a little bit below the plus you write water and write the formula above it in the line with plus. So here we see, now calcium carbonate we know is a salt. So here we see this one is reacting with a base. What is reacting with this base? Carbon dioxide, non-metallic oxide is reacting with base to give you salt and water. We just few minutes back we learned that only acid can react with base to give salt and water. So definitely carbon dioxide is acid, which means non-metallic oxides are acidic. Just before that, metallic oxides are basic, we learned, so they are opposite. And non-metallic oxides are acidic. Okay, so that explains it. So let us come here to your question. So here you see 23 and 24. Metallic oxides are basic and non-metallic oxides. Oxides is missing in your note, okay? So write that one, oxides. Non-metal oxides are acidic in nature. Explain with suitable example. Combine question 22 and 23, then you'll be able to answer that question. Then textbook question. Okay, read 23, pause the video, make sure you're understanding, go to 25. Now this is textbook question. Why should curd that dahina and sar substance tinga curd should not be kept in brass or copper vessel? It's on your textbook, so I just found the answer and gave you. So nothing to explain, you read them and understand yourself. Okay, and then question number 26, important. Okay, so go to question number 26. Now on question number 26, here, question number 26, we have here, the question is saying, which gas is liberated when acid react with metal? So take your page. What gas will be liberated when acid react with metal? Acid plus metal. What gas gives? Question is saying, if you react acid and metal, what gas you'll get? This is what the question is. Gas, oxygen or hydrogen or nitrogen, like that. Go to page 47. For this, you need to make sure that you take a metal which is above hydrogen. So on page 47, there's an activity series of metals. This is hydrogen, as you can see. Any metal above hydrogen you can take: lead, metal, iron, zinc, aluminum, magnesium. But avoid the one just immediately above hydrogen, then you'll get better reaction as you go up. So let's take zinc, because zinc is cheaper and easily available in your school laboratory. That's why I'm saying. So you take this zinc metal. So here, okay, so for this you take here zinc. So write that zinc, add that to the acid. So you say here the common acid is hydrochloric. Okay, write it properly, hydrochloric acid. All right, here HCl. So this react. Then on your note I wrote zinc first and HCl second. Same thing, okay? HCl plus Zn or Zn plus HCl is the same. It's up to you. Now just now you saw on the table that Zn is well above hydrogen, this hydrogen. So that means it's more reactive than hydrogen. So it'll easily push out this hydrogen from HCl and form the hydrogen gas H2. So that gas will come out of your test tube in bubbles. You can actually see the gas bubbles. Okay, no color because hydrogen is colorless. Then what will be the next? Zn and Cl combined means surely a little bit below the plus. No need to memorize this. Zinc chloride. There is no other possibility. You know that from starter. Write the formula by remembering starter. Zn 2 plus. Don't look here. Look here. And make the formula by remembering starter. Cl1 minus 1 and 2 means can't cancel. 2 will go at the back of Cl. So ZnCl2 zinc chloride, not ZnCl. You know, not starter. So next job, as we said, what do we do? Yes, balance. So H1 and here 2. We cannot balance middle or back. So right here 2H, H2. So now balanced. Then 2Cl, Cl2, Zn. So it's balanced. Now second part of the question is saying we know that a gas bubble is coming out, but how do we know it's hydrogen? So you pass this hydrogen gas through a soap solution. Soap solution mane surf ulop loina bucket ta halina batik tare ina kole the soap bubbles itu soap solution do ko the surf detergent la na. So the pipe ekta ra hydrogen gas ola do pass kule balloon nisna soap bubbles kan ola wo bahar. To candle ekta ni na julai gina itu gas bubble ekta julai sabi. This gas inside the bubble will burn with blue color flame, with blue flame, and burn with popping sound. Itu mokai khan popcorn pop 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 na popping sound. So the sound will be something like push, like that. It will come out. The only gas that can burn with blue flame and popping sound is hydrogen. So that proves that the gas liberated by reaction of metal with acid is hydrogen. Na? So that explains your question number 26 here. See, which gas is liberated when acid react with metal? Hydrogen. Illustrate with an example. We have done that example, zinc and hydrochloric acid. How will you test for the presence of this gas? Burn the candle on the hydrogen gas. It burned with blue color popping sound. All done, right? So that will conclude the video. Okay.